Okay, this is CET236 homework number 4, question 3 on nodal analysis. And this one's a little bit trickier, right? Because we've got 4 nodes this time. So we're going to get 4 equations out of it, A, B, C, D. Because we've got 2 voltage sources, we're expecting to have to replace 2 of our KCL equations with KVL equations. So we get 2 and 2 for this one. And then the first one is the freebie, VA equals V1, and V1 is 30 volts. The second one is pretty quick too. VB minus VC is V2. V2 is 21. So that gets us those first 2. Then the super KCL. So remember, we need to draw a box around the voltage source that's connected between the 2 non-reference nodes, and then I've just taken these currents as the currents that flow into that box, into that supernode. So the first one is VA minus VB on R1, which is that one. Then there is 0, because that's the reference node, minus VC on R2. And it looks like I've got the order wrong. That's okay. There's VC on R2, minus VC on R2, and then this one is VD minus VC on R3, and R3 is 8K, so that's that one. Then the KCL at D, and I've just chosen that for my direction for IR4. So it's, because this one's flowing out, it's minus VD minus VC on 8000. 8000 was our R3 value. And then it's 0 minus VD on R4, which is our which is 2000. So we get minus VD on 2000. I can then solve that, I think, using those equations there. And let's just make the color a bit better so it shows up a bit, and maybe make it a bit bigger. Right, so there's our equation there. I think my A matrix is now 4 by 4, so it's a little bigger than normal. And the answer I get is VA is 30, VB is 25, VC is 4 volts, and VD is 0.8 volts. Then the answer I need is just going to be I out, which is the same as my IR1, VA minus VB on R1. So VA minus VB on R1, so that's 5 volts divided by 2500 ohms, which gets me 2 milliamps or 0.002 amps. And that's question 3.